Astronomers have found a strange structure near the Andromeda Galaxy that is almost as large as the galaxy itself. This discovery baffled astronomers because the world's best telescopes had never noticed this gigantic ring-shaped structure before. The find was made by amateur astronomers using a comparatively cheap telescope. Now, scientists are puzzling over exactly what the structure is and wondering what else they might have overlooked in the universe. The Andromeda Galaxy, also known as M31, is no longer a particular highlight for astronomers. Our neighboring galaxy, with its majestic spiral structure stretching over 220,000 light-years, is considered very well-researched and has been photographed and analyzed thousands of times. Andromeda is twice the size of our own galaxy and is home to about 1 trillion stars. On a clear night, it can be seen as a delicate glowing spot in the sky, a fascinating sight that inspired 3 amateur astronomers from the United States to take some very special pictures of the galaxy. To make our neighboring galaxy shine in a special light, the 3 used different color filters. This revealed a structure that had escaped the best astronomers on Earth. The structure had been directly in view all this time, but its peculiarities made it difficult to see. The dimensions of the formation alone are alarming. The mysterious structure is almost as large as the Andromeda Galaxy itself. This really makes us wonder how a structure of this size could have been overlooked for so long. The answer to this question is quite simple. The newly discovered structure consists only of the finest gas, similar to the fine rings around Uranus and Jupiter, which could only be seen with very advanced technologies. The same applies to the strange structure that half envelops the Andromeda Galaxy. The 3 discoverers used a special filter that only lets the light of doubly ionized oxygen through. Through this filter, the gas cloud produced a mysterious blue-green glow that is normally invisible to the human eye but was impressively highlighted by the technique used. After the amateur astronomers reported their discovery, it was confirmed by professional scientists using data from several telescopes in France, California, and New Mexico. No one knows what this structure really is. Interestingly, researchers have so far been unable to explain why this huge structure has remained undetected until now. Large data sets from different parts of the electromagnetic spectrum, such as X-rays, ultraviolet, and infrared light, showed no evidence of this gas cloud. It was also ruled out that it was an error in the image processing or stray light. The significance of this discovery is far-reaching. Some astronomers suspect that the structure could be an indication of the beginning interaction of the galactic halos of Andromeda and the Milky Way, since both galaxies will collide in about 5 billion years. However, the exact origin and nature of this structure remain a mystery to be solved. The structure could be an early sign of the impending merger of Andromeda and the Milky Way, as the galactic halos, the huge, almost invisible shells of gas, dust, and dark matter surrounding the galaxies, may already be interacting. Both galaxies are moving towards each other at a speed of about 110 kilometers per second and will collide in about 5 billion years. When their halos begin to overlap, processes such as gravitational influences or shock waves could arise that alter the gas distribution and cause emissions like those from the discovered structure. The huge gas cloud that this structure represents could be the result of such interactions, in which gas between the galaxies is compressed or heated. Furthermore, the cloud could have been created by galactic winds or currents that were intensified by the approach. This discovery, therefore, provides valuable insights into how early phases of galaxy mergers occur. Have scientists made a mistake? The statement that previous investigations have found no evidence that this structure is an artifact means that researchers have ruled out the possibility that the observed structure was caused by technical errors, image processing problems, or stray light. This was confirmed by comparison with data from different wavelength ranges. But what are wavelength measurements in astronomy? Celestial objects are studied through their electromagnetic radiation. This radiation encompasses various wavelengths, ranging from short-wavelength X-ray and ultraviolet (UV) light to long-wavelength infrared (IR) or radio waves. Since every physical phenomenon, for example, gas, dust, stars, or black holes, emits specific radiation that depends on the wavelength, astronomers can gain a comprehensive picture of an object by using multi-wavelength observations. What are these measurements good for? Multi-wavelength datasets are crucial for a complete understanding of cosmic objects and processes. X-rays, often emitted by extremely hot gases, for example, by shock waves or round black holes, show active processes in galaxies. UV light reveals young, hot stars and regions of intense star formation. Infrared light captures cooler material, such as dust, molecular clouds, or faint galaxies that are obscured optically. What do these measurements show in terms of structure? For the discovered structure near the Andromeda Galaxy, previous studies in all these wavelength ranges have not found any emissions, which makes it all the more unusual. Gas clouds would normally emit infrared or UV radiation, for example, but the fact that it's only visible through the blue-green light of ionized oxygen suggests that this gas cloud represents a very special physical phenomenon, either extremely thin, unusually composed, or shaped by processes that only occur in certain phases of galactic interactions. The mysterious formation near the Andromeda Galaxy has left scientists with numerous questions. Here are 3 possible explanations for its origin, along with an additional hypothesis that goes beyond the current framework. Hypothesis 1. A relic from earlier galactic interactions. The structure could be a remnant from an earlier encounter between Andromeda and a smaller galaxy. In such cases, gas and dust streams are often torn out of the galaxies during gravitational interactions, forming gigantic gas clouds or bridges. These relics often have a unique chemical composition and could correspond to the special oxygen emissions from the formation. Since Andromeda has a history of swallowing dwarf galaxies, this structure could be a not yet fully integrated remnant. Hypothesis 2. A previously unknown cosmic nebula structure. Another explanation could be that the formation is a giant emission nebula that has been ionized by a previously unknown source. Such nebulae often form when radiation from hot stars or supernovae ionizes the surrounding gas, creating specific emissions. The fact that the structure is so large and consists of ionized oxygen could indicate that it was influenced by an extremely massive event, such as an ancient star-forming region or even an active galactic nucleus. Hypothesis 3. An intergalactic gas cloud. It's possible that the formation does not directly belong to the Andromeda Galaxy at all, but represents a huge intergalactic gas cloud that has been drawn close to Andromeda by gravitational forces. Such clouds could be remnants from the early phase of the universe when galaxies and galaxy clusters formed. Its isolated position and composition could indicate that cosmic currents have pushed it into the vicinity of Andromeda. Hypothesis 4. A signature of dark matter or exotic processes. One daring hypothesis would be that the structure is an indirect indication of interaction with dark matter or exotic physical processes. Dark matter could have influenced or compressed the gas in the formation, causing it to ionize. This idea could explain why the object was so difficult to detect and shows no signatures in other wavelength ranges. The discovery of the mysterious structure near the Andromeda Galaxy is a striking example of how much of the universe remains undiscovered, even in relatively well-studied regions like our cosmic neighborhood. The fact that this gigantic formation has been overlooked despite decades of observations by the best telescopes raises fundamental questions about how much of the actual structure and composition of the universe has remained hidden so far. The significance of the discovery is profound. This structure could indicate that the cosmic gas web of the universe, consisting of giant gas clouds, filaments, and halos, is still largely unexplored. However, these gaseous structures play a crucial role in the formation and evolution of galaxies. They supply galaxies with fresh gas for star formation and influence their evolution through gravitational and streaming effects. The fact that such a formation has only now been discovered suggests that many other similar structures, perhaps even larger or more complex ones, may exist that are not yet visible through conventional observational methods. This could mean that there are gaps in our understanding of galactic interactions, star formation, and cosmic evolution. What else could be hiding? Undiscovered intergalactic gas clouds. Many of the giant gas structures that form the filamentary network of the universe have not yet been mapped. These filaments connect galaxy clusters and could contain the missing baryonic material that astronomers are looking for in the mass balance of the universe. Hidden star formation. Gas clouds that are invisible in certain wavelength ranges could harbor undiscovered sites of intense star formation. Dark matter and gravitational lensing. The discovery also shows that dark matter structures, which dominate the universe, could affect gas clouds and their dynamics and reveal invisible interactions. How can scientists discover such structures? Expand multi-wavelength methods. The use of specialized filters, as used in this discovery, is crucial. Future telescopes could specifically examine wavelength ranges that have been neglected so far. Involve amateur astronomy. The discovery by amateur astronomers shows that broad participation and creative approaches can open up new possibilities. New technologies and algorithms. Advances in AI and image processing could help detect fine structures in existing astronomical data that have been overlooked so far. The implications for research are clear. The discovery makes it evident that our models of the universe must remain dynamic. It shows that crucial pieces of the puzzle for our understanding of galaxy formation, cosmic structure, and the interaction of matter in the universe are still missing. Every new discovery could fundamentally change our view of the cosmos.